Now let's discuss how to insert an element in the middle of an array. I'll start with preprocessor directive #include stdio.h. The execution of the program always starts from the main function. I'll declare a variable n to get the size of an array. Scanf %d comma ampersand n. So I have declared the size of an array. Now I have to declare an array. So I'll give the array size is 10. Okay. So when I give int arr of 10, automatically it allocates 10 blocks of memory. So let me block 10 blocks of memory. I'll give the array name as arr. Fine. I'll allocate memory also, so that it will be easy for us to know. 1000, 1004, and it goes on like this. Okay, it allocates 10 blocks of memory. Fine. Now I'm going to get array elements from the user. For int I is equal to 0, I less than n, I plus plus. So scanf %d comma ampersand arr of I. Fine. So I've got the array elements. Now let us assume the size of an array is 5. I'll get 5 elements from the user. Let's assume I'm going to give the input value as 10, 20, 30, 40, 50. I've got 5 elements from the user. Now what am I going to do? I have to insert an element in the middle. So let me give a position. So let me get at which position I want to insert an element. I'll declare a variable called position. I'll get the position value from the user. Scanf %d comma ampersand pos. Here let us assume I want to insert at the second position, not the index values. Remember this very clearly. I want to insert an element at the second position. So here first position is 10, second position is 20. So here I want to insert one element. Okay. So position I have got from the user. So position number 2. So in the position number 2, what value I have to insert? So let me declare a variable called value. I'll get from the user. Scanf %d comma ampersand value. So here I'll give, for example, I want to insert the element called 15. The second position I want to insert the value called 15. Okay. Now here in the second position I want to insert the value called 15. So if I want to insert, what I have to do? I have to right shift all these elements. Okay, I have to right shift all these elements. First, what I have to do? First, let's discuss the logic. First, I'll go to the last index value. I'll take this value 50 and I'll right shift by one step. So this 50 will be moved to this place. Now I was here, right? Okay. Next, I'll come to this place. I'll take this element 40. I'll move to this place. Next, I'll come to this place. I'll take this 30 and I'll move to this place. Next, I'll come to this place. I'll take this 20. I'll move to this place. So I have right shifted all the elements. Now here on the index value 1, that is position 2, I'll insert the value called 15. So now I have inserted the element in the position 2. So this is the disadvantage of an array. Why? Because the element stores in the continuous memory allocation. If I want to store any element in the middle or in the beginning anywhere else, I have to right shift the elements. So right shifting the elements will take some extra time. That is why we say this is a disadvantage of an array. Why this disadvantage? Because of the continuous memory allocation. But when you are fetching the elements, it is very easy. I don't want to traverse. Directly I can fetch the element because of the continuous memory allocation. So because of this continuous memory allocation, it has disadvantage as well as advantage also. Based on the scenario, we can get to know either to use this array data structure or not. Now let me write it as a program. So here what I have to do first I have to go to the last index value. So that is taken by int I equal to n minus 1, because the index value of an array starts from 0, ends with size -1. That is why n elements I'm going to get n minus 1. On the index value n minus 1, I'll have the last element. Till which position? That is, I have to go I greater than or equal to position -1. And then I have to decrement. So now what I'm going to do, the iteration starts with n minus 1. N value is 5. 5 minus 1 is 4. Let me give index value here. 0, 1, 2, 3, 4. Now I is in the index value 4 because I have been n minus 1. So here the value of n is 5. 5 minus 1 is 4. So I'll start the iteration from the index value 4. Okay. Now check the condition. I greater than or equal to POS minus 1. What is the POS? 2. 2 minus 1. That is 1. 4 is greater than or equal to 1 because I have to come till this position. So 4 greater than or equal to 1. Yes, condition is true. If the condition is true, what I have to do? I have to take this element. ARR of 4 has to be taken. That should be stored in ARR of 5. Index value 5. ARR of 4 should be taken. That should be stored in ARR of 5. ARR of 4 is ARR of I. ARR of 5 is ARR of I plus 1. So ARR of 4 will be taken. That will be stored in ARR of I plus 1. So ARR of 4 value is 50. That will be taken and that will be stored in ARR of 5. This 50 will be taken and that will be stored here. Done. After this, what I have to do? I have to decrement the value. So now I value is decremented by 1, which becomes 3. 3 greater than or equal to 1. Yes, condition is true. If the condition is true, what I have to do? I have to take the value from ARR of 3. Y value is 3, right? I have to take the value from ARR of 3. That should be stored in ARR of 4. This value will be stored here. After this, what happened? I'll go to the next iteration. I value becomes 2. 2 greater than or equal to 1. Yes, condition is true. So ARR of I value is 2. That will be taken and that will be stored in ARR of 3. Done. I'll go to the next iteration. I value becomes 1. 1 greater than or equal to 1. Yes, condition is true. So what I'll be doing? ARR of 1 value is 20. Okay. I'll take this value. I'll store it in ARR of 2. Done. I've copied this value here. Now I'll try to go for the next iteration. I value becomes 0. 0 greater than or equal to 1. Condition is false. Now what happened? I have right shifted all the elements. Now in this position, I have to insert the new value. So what I'll be doing? I'll come out of the for loop. Now I want to go to the index value called 1. So position value is 2. So what I'll be giving? ARR of POS minus 1. Position is 2 means index value is subtracted by 1. So here what I'll be doing? I'll store the value called 15. So 15 is a value that is stored in the variable value. That value will be taken and that will be stored in ARR of POS minus 1. POS value is 2. 2 minus 1 is 1. On the index value 1, I'll store the value called 15. That's all. I have inserted the element. After that, increment my n value. Why am I increment my n value? Earlier I had n elements. Now I have n plus 1 elements. So n value has been incremented by 1. Now let me print those elements. I equal to 0, I less than n, I plus plus. I'll give printf %d. I'll give a space so that we can get to know the different elements. ARR of I. That's all. Let me save this and let me run the code. Let me give n value as 5. I want to give 5 elements. 10, 20, 30, 40, 50. So I have got all the 5 elements from the user. Now I want to insert the position. So I want to insert at the, here I'll give third position. Okay. So 10, 20, after 20 I want to insert a value. So position value is 3 I have given. Fine. Now I want to insert which value? Let me give 25. Okay. I have given 25. See, after 10, 20, third position 25 is inserted. All the value has been right shifted. 30, 40, 50. That's all. Now let's discuss how to delete an element from the array. I'll start with preprocessor directive hash include stdio.h int main. Fine. So I'll declare an array of size n. I'm going to get n elements from the user. Scanf %d ampersand n. So I have got the size of an array from the user. Now I'll declare an array. I'll give ARR of n itself. Now I'll get the array elements from the user. For int I is equal to 0, I less than n, I plus plus. So what I'm going to do? I'm going to get the array elements. Scan of %d, comma, ampersand arr of I. I've got the array elements. Okay. Here instead of n, I'll give 10. Better. So when I give int arr of 10, what happened? 10 blocks of memory will be allocated. After that, I'm going to get only n elements from the user. Let us assume the value of n is 5. So which means I have to give 5 elements. So I'll give the array name as arr, 5 elements. 10, 20, 30, 40 and 50. I've got 5 elements from the user. Index value is 0, 1, 2, 3, 4. Done. I've got the array elements from the user. Now I want to know which position element has to be deleted. So for that I'll declare a variable called POS. Let me get the position value from the user. %d, comma, ampersand POS. Let's assume I'm going to delete the element which is at the position 3. Let me give 3. So position 1, 2, 3. So I have to delete 30. That is the meaning. Now before deleting, I have to check one condition. Before deleting the element, I have to check whether the position which I am going to delete is valid or not valid. For that, I have to check the condition. If position value is less than 1, because the position starts from 1. If the value is less than 1, or if the position value is greater than n, because I have only n elements, if I give more than n, I cannot delete the element. So I'll give a message saying that invalid position. If the condition is false, I can delete the element from the array. So I'll go here. Now I have to delete the third position. First let's discuss the logic and then we'll go for the program. If I want to delete, what I have to do in the sense, I have to left shift this element from here to here. Then this element from here to here. Then the size of an array will be decremented by 1, which is 4. Because I have 5 elements earlier. Now I have only 4 elements. So this is the array element. This is how I have to delete an element. So to delete an element, I have to left shift the elements. This is the logic. Now let's go for the program. Okay. So I have to start the iteration for int I is equal to POS minus 1, I less than n minus 1. Why am I giving n minus 1? Because if I delete one element, the size will be decremented by 1. So that is why I am giving n minus 1 and then I am giving I plus plus. So here what is the position value? My position value is 3. 3 minus 1 is 2. So I am going to the index value called 2. Right? Because this element has to be deleted. So what I am going to do is 2 less than n minus 1, n minus 5, 5 minus 1, 4. 2 less than 4, yes, condition is true. I'll go here. What am I going to do? I'm going to take this element. I'm going to take 40 and that should be stored in the index value 2. I'm going to take the value 40 and that should be stored in the index value 2. So what I'm going to do? I'm going to give ARR of I is equal to ARR of I plus 1. So I'm going to take the next element, that is 40, and that will be stored in ARR of I. So here 40 will be taken and that will be stored in the index value 2. So here ARR of I value is cut. ARR of I plus 1. I value is 2. 2 less than 4, condition is true. I'll take 2 plus 1, 3. ARR of 3 value will be taken. 40, it will be stored in ARR of 2. Done. After that, I'll go for the next I value. I value becomes 3. 3 less than 4, yes, condition is true. Which means I'm going to take the value from the index value 4. That will be stored in 3. So 50. Then I'll go to the next iteration. I value becomes 4. 4 less than 4, condition is false. I'll come out of the for loop. After coming out of the for loop, I have to decrement the n value by 1. Because earlier I have n elements. Now I have n minus 1 element. So n minus minus. That's all. I have deleted the element. Now I have elements in these 4 index values only. So when I start printing the values, I'll give int I is equal to 0, I less than n I plus plus. So printf %d, comma, I'll give a space so that it's easy for me to know ARR of I. That's all. That's all. Let me run the code. I have to give n value 10, 20, 30, 40, 50. Now I have to give the position 3. See, 30 has been deleted, 10, 20, 40, 50 has been printed. That's all.